Hello everyone, I welcome you all to our presentation titled Greenway on Street Canyon of Residential Areas in Dhaka, Missing Link of Possible Impact in Taming the Thermal Comfort. I am Professor Ashik Jordar, Professor of Environment and Energy, Department of Architecture, BUE Dhaka, and my colleague, Architect Tasnim from Department of Architecture, BUE Dhaka, will present our paper now.
Once upon a time there was an ancient city, a city featured by orchards and meadows, a city that we call Dhaka. Good time, I am Zareen Tasnim. Today I will depict a tale of Dhaka, the capital of Bangladesh. Gradually, rapid urbanization has replaced the pasture of Dhaka with edifices. Current Dhaka embraces amplified outdoor air temperature and uncomfortable urban spaces. Dhaka hails residential uses and lacks pedestrian precinct. Greenways are linear open spaces built along plush green, stream or similar trails for strollers. Could the implicit integration of greenways on the street canyons of planned residential Dhaka contribute in lessening the elevated city temperature, ensuring pedestrian thermal comfort? Microclimatic parameters are involved in outdoor human thermal comfort. For example, dry bulb temperature (dBT), relative humidity (RH), mean radiant temperature (TMRT), and wind speed (WS). Tropical studies painted that urban street trees reduce dBT, TMRT, and increased RH. Permeable pavement means human thermal comfort, reducing TMRT in hot periods. Many reviews voice Greenway boons in amending environment, yet research uttering urban Greenway pluses in enhancing thermal comfort is rare. To connect the missing link amid greenways and their likely impact in taming the thermal comfort indices of urban street canyon microclimate, we assessed the integrated greenways plausibility in ameliorating thermal comfort indices of PR Dhaka's street canyon microclimate, raising pedestrian thermal comfort. We selected Section 12, Pallavi Mirpur Dhaka for study. Section 12. This lower wedge area of less foliage, extra exposed concrete footpath and asphalt road surfaces cause high ambient and radiant temperatures and thermal discomfort to the denizens. We inspected primary, secondary and tertiary roads at 8 points. Ample pedestrians use these streets. We explored the microclimatic parameters dBT, RH and WS at 8 existing bare and Greenway identical GI points. Point 1 to 8 of PR Dhaka selected street canyons at 1.5 meter above ground level, pedestrian level. The GI street canyons contain high leaf area density LAD and high leaf area index LAI trees densely planted on both sides. Using thermoanemometer and hygrothermometer, we logged dBT, RH and WS at 1 hour interval from 10 to 18 hours from March 2017 to 2018 on several summer days. Point 2 was bare and point 1 was near a tree-covered cemetery. Point 3 embraced buildings at one side and a small tree strip on other side. Point 4 embraced building at one side and tree vast linear area on other side. Point 5 was on a bare road and point 6 was on a road lying many large trees linearly placed on both sides. Point 7 was on a bare road, point 8 was on a road holding plentiful huge trees linearly set on both sides. Bad point 7 and green point 8. At 8 study points, average dBT was logged 0.73 to 1.34 Kelvin lower at green or GI points than bare point from 10 to 18 hours. Average RH was logged nearly similar or higher 0.44 to 1.58% higher at green or GI points than bare points from 10 to 18 hours. The GI street canyons showed lower average WS from 10 to 18 hours. Given no existing greenway on Dhaka's street canyons, NVMed Summer 18 software modeled and simulated one major existing bare street canyon, bare point 2 at Khalshi Road from 8 to 20 hours. The same software integrated Greenway on same bare model, termed Greenway Point 1 and simulated for same hours. The Greenway model applied a pedestrian trail paved with permeable interlocking concrete pavement PICP hemmed in many densely planted Delonix resia using Albedo 430 and NVMed. Sectional simulation model of Greenway Point 1. The simulation study revealed that the average DBT was 9.07 Kelvin lower at Greenway point 1 than Bear point 2 from 8 to 20 hours. The average RH was 13.06% higher at Greenway point 1 than Bear point 2 from 8 to 20 hours. The average TMRT was 21.82 Kelvin lower at Greenway point 1 than Bear point 2 from 8 to 20 hours. The average WS was lower at Greenway point 1 than Bear point 2 from 8 to 20 hours. The field study reveals that Dhaka's Bear Street Canyon is thermally uncomfortable for the pedestrian. At daytime, the DBT remains higher than the thermal comfort level. At PR Dhaka, the GI Street Canyons enhance the microclimate and outdoor thermal comfort, containing lower DBT up to 0.73 to 1.34 Kelvin. At some points, DBT within thermal comfort level 22.5 to 30 degrees Celsius, higher RH up to 0.44 to 1.58%. The simulation study unraveled that integrated greenways on USC at PR Dhaka can offer thermally comfortable microclimate for the pedestrians, reducing DBT up to 7.03 to 10.30 Kelvin, increasing RH up to 7.90 to 18.47%, and reducing TMRT up to 5.76 to 31.36 Kelvin. This research establishes that integrated greenways consist an inherent cooling effect on street canyons of PR Dhaka. Over field and simulation study, this research reveals that Greenway leverages reducing DBT and TMRT and increasing RH of USC microclimate. Integrated greenway on USC enhance pedestrian thermal comfort. Concisely integrated greenways on street canyons of PR Dhaka can deliver the urbanized, thermally comfortable, benign and pleasant urban walking environment. And the denizens of Dhaka would live happily ever after. Thank you. Muchas gracias.